We're asked to determine if there is a maximum, a minimum, or neither at the point given, and we're given a differential equation, dy over dx, which is the derivative, equals x cubed minus y squared, where f of 1 equals 1. That means that they're telling us that we have a point 1, comma 1, because there's our x and there's our y. All right, so we're given this particular solution, and what we need to do is we need to figure out, well, what's happening at that point? Do we have a maximum or minimum or nothing? Now, in order to do that, we are going to use the second derivative test. And the second derivative test tells us that if the first derivative equals 0, then we can test the second derivative to see if it's a maximum or a minimum. So first we need to see if the first derivative does equal 0. So we're going to say dy dx equals, and we already have that up here, so at 1 comma 1, 1 cubed minus 1 squared. So we get 1 minus 1, which does equal 0. Okay, great. So we do see that the first derivative is 0. So we can use the second derivative test. So the next step that we have to take is we have to find the second derivative. To do that, I'm going to do this in red. We have to find the derivative of this equation up here. So that means d squared y over dx squared, our second derivative, is the derivative of that first term. We're going to use implicit differentiation here. So 3x squared minus 2y, and the derivative of that y is dy dx. Now, again, we are going to plug in the value that we already know dy dx equals. We can see that at the top, and I'll highlight it. We know that dy dx equals x cubed minus y squared. The question told us that at the beginning. So we can see 3x squared minus 2y times x cubed minus y squared. And then our next step is we need to figure out, well, what's happening at that derivative? So at a specific point. So we want to look at it at 1 comma 1. What's happening at 1 comma 1? So we're going to plug in our values. 3 times 1 squared minus 2 times 1 times 1 cubed minus 1 squared. All right, so I know that this right here, 1 cubed minus 1 squared, is going to give us 0. 0 times anything will be 0, so all of that will become 0. So this just equals 3 times 1, which is 3. Now, it doesn't really matter exactly what this number is, but it does matter what sign it is, because we're looking at the second derivative, and I see that it's greater than 0, which means that the second derivative is positive. When the second derivative is positive, I'll draw this example, we know that we have a concave up function. And we saw earlier, up here, that the first derivative was 0, which told us we had a minimum or a maximum. And what we can see here is if we have a concave up function and we have some extreme point, we can say that this is a minimum, because we saw that the derivative was 0 and the second derivative was positive. And so that's how we'd write our answer. We have a relative minimum at the point 1 comma 1 because, and we have to write this, because dy dx at that point equals 0. That told us that we had an extrema. We knew that there was something happening there, but we needed to figure out what. And the second derivative at that point was greater than 0. Knowing both of these things tells us that we have a relative minimum at that point.